only in recent years have we really begun to understand how the brain works. And one of the most exciting things about this new information is how the brain actually develops from the very start. What is it that happens until we get to these walking, talking, understanding, most of us mathematically competent people that can do all these adult things. Now, the easiest way to actually explain brain development is for me to use this piece of paper. And what happens essentially in the very first few days after conception is that as the cells start dividing, they actually form what we call a neural plate. So very similar to this piece of paper, just a layer of cells that kind of look like a plate or literally like a piece of paper. And after a few days, this neural plate begins to fold and almost roll up like this. And we call that the neural tube. So within this neural tube, there are 3 layers that develop. The inside layer will become the central nervous system and the brain stem eventually. The middle layer will become the organs, and the outer layer will become the skin. And what's very interesting is that we find that because these 3 layers all develop at the same time, when there's a problem with brain development or a problem within the central nervous system, that often shows up in skin problems. So very often in my practice, I'll find that children who have attention deficit disorder or a difficulty with concentration will present with skin problems like eczema or allergies or something like that. And that gives us an indication that we also need to perhaps look for difficulties within brain development. And one of the problems we have in the brain is that we have this machine that can do all of these amazing things, but we've got this very limited capacity within the skull to fit it all into. So as the brain starts swelling and these brain regions start developing, the brain actually starts folding in on itself. And if I show it to you like this, if you can imagine that this is the spinal cord and the brain stem, and then we have the 4 lobes of the brain, so the occipital lobes, the parietal lobes, the temporal lobes, and then the frontal lobes. And very importantly is that it actually develops in this fashion. Now, brain development is fantastic. It's wonderful, it's amazing, but it's not an exact science and it's not 100% perfectly well organized and designed. So it's not like your brand new iPhone or something that's sleek and it works all together. It's a little bit more like an ice cream cone. So as we've developed and as we've gone through different evolutionary stages, your brain's kind of just lumped things on top of each other as we get better and better at them. Now, at the very bottom, that first ice cream scoop is where we actually have the things most essential to life. So breathing, consciousness, things that we need to survive are at the very bottom. And it's brilliant because that part of the brain is at the very back of the skull, where your skull is thickest and where it's the least likely to actually get injured if you were to fall or to have an accident. So that kind of ensures our survival. And then as we've become more and more sophisticated and learned to do more and more things, those different aspects have kind of just been lumped on top of that, like different ice cream scoops. So from the back of the brain, we then get our senses and sensory perception, being able to see, being able to hear, language development, and at the very front of the brain is almost our new skills that we haven't always had throughout the evolutionary path. Things that we call executive functioning, like being able to plan, being able to pick up on social cues from other people. And if you look at that, the brain also, as it starts developing, because these are the oldest parts of the brain, they start developing very early on. But the frontal lobes, where we have that executive functioning, only starts happening much later in childhood. So the frontal lobes keep developing. And for that reason, we might find that a lot of children don't necessarily have those skills that we expect in the beginning. So young children are very egotistical. They won't necessarily be able to understand social cues from other people or what it is that other people want from them. They battle with planning. They can't always think ahead. They can't handle abstract thoughts or abstract concepts. Now, a little piece of brain about the size of a grain of rice has almost 10,000 brain cells. And all of those 10,000, each and every one of those brain cells is able to make up to about 10,000 connections with other brain cells. So you'll see how everything in the brain needs to work together. But initially, only a few of those neural pathways are actually laid. And as your child develops, more and more neural pathways actually become set. And we know that repetition is very important. So as you do things with your baby, make sure that you repeat them over and over so that becomes a skill that's well practiced. Another important thing that happens not only during pregnancy, but as your child grows, is a process called myelinations. If you look at a brain cell, the brain cell actually has the core, which is the nucleus of the brain cell, and then it has dendrites and axons. So dendrites gathers information from all the other cells around it and all the other synapses and brings that information into the brain cell, whereas axons carry that information away from the brain cell to new brain areas and new axons and synapses. And what is very important in that process is that the brain actually sends an impulse or a message through these neural pathways in an electrical form. It's an electrical current. And if you think about it like electrical wiring and electrical insulation, that ensures within that axon, it makes sure that that electrical impulse gets carried through effectively from the top out to the bottom where it's delivered to other brain cells. And myelination, again, is something that starts happening in pregnancy, but will only really be complete by the time a child reaches their teens or even early adulthood. So keep in mind that your child's brain is slightly different to yours, and that it'll take a while before some of the skills they'll be able to develop. So every little interaction with you is going to help build those neural pathways and strengthen them so that they can become the foundation on which more knowledge is built. And that's the way in which we can handle increasingly more complex information throughout their lives.